الألماس.
دكتور
بإمكانكم تنزلوه وتبدوا في حله. هو يعني حتى التعليمات وكل أموره يعني موجودة في الألماس، باستثناء راح أنزل تعليم بخصوص السكتش. في عندنا سكتش في واحد من الأفرع في رسمي، مطلوب منكم رسمي. هذه بإمكانكم ترسموها باي هاند أو using any software. أوكي، أي برنامج برسم. الفكرة في ال TMA ممنوع نهائيا تحله بخط اليد. أي طالب بحل بخط اليد لأي سؤال راح يحصل على 0. ممنوع نهائيا خط اليد باستثناء هذه الرسمة مسموح إنه ترسموها في خط اليد، وراح أكتب هذا الشيء والتعليمات واضحة في الLMS. بس بخصوص هذه الرسمة راح أضيف تعليمي، يعني إحدى التعليمات بخصوصها. TMA تقريبا يعني اليوم وصلني الديدلاين، أتوقع يعني راح يكون في وسط 7. راح أبلغكم بشكل رسمي في الLMS. طبعا الديدلاين أنا أتحدث عن البلاجرزم، راح يطبق ويطبق بجدية عالية، ويعني خلينا نحكي فيه بقوة، يعني ما في أي تهاون فيه. حلي مع زميلتك، حل مع زميلك كما شئت، بس لما تيجي تكتب اكتبه بلغتك. ليش ما بنشوف التشابه في الاختبارات اليدوية؟ نفس الشيء بدنا نشوفها في الاختبارات الإلكترونية. يعني لما يكون نفس الخطأ ونفس الفاصل ونفس الانتر ونفس التعليق ونفس الجملة ونفس الترتيب والتنسيق، هنا 5 خطوات هون 5 خطوات، لا هذه رياضيات. احنا ممكن نحله ب5، ممكن ب6، ممكن ب3، ممكن نحكي تعليق، ممكن نزيد أكثر استفسار. كل طالب يعني بإمكانه يعمل اللي بده إياه. اكتبه بلغتك، حله كما شئت مع زميلك، لكن اكتبه بلغتك. وما حيجيني طالب يقول لي أنا ما غشيت. ما في هذا بينزل على السيستم وبيقرأ جملة جملة، والجملة اللي متشابهة، الفقرة المتشابهة راح يحط عليها بلاجرازم ونسبة تشابه. انت لما تيجي تكتب بالاختبار تأكد انه منشوف أجوبة ما إلها علاقة في بعض وكلها صحيحة، والخطوات ما إلها علاقة في بعض. احنا نتحدث عن نسب عالية، انا ما اتحدث والله النسب التشابه بكل شيء، انا اتحدث عن نسب عالية. يعني انت توصل نسبة تشابه 90% راح تاخذ 0. 80% فما فوق من 80 ل 89 ممكن توصل تخسر نص قيمة الاختبار، وهكذا. أنا نبهت وما حدا يجي يقول لي أنا ما غشيت. أنت لو عملت شير لملفك وسرقوا أحد بهذا المعنى، سرقوا أحد يعني صاحبك أو صاحبتك أخذته وقالت لك راح أغير عليه وما غيرت وعملت له أبلود، أنت راح تأخذ 0 زيك زيها، لأنه أنت هذه محاولة غش. سواء أنت غشيتي ولا ما غشيتي، أنت غششتي، نفس المبدأ. فأتمنى أنه تكونوا يعني جديين بشغلة البلاجرزم. هذا التشابه ما في تهاون، لأنه بروح للبريطان وما يحاسبونا عليه بالتقرير اللي بيطلع من مواقعهم. لا ما في اختصار يا خمر، اكتب بالتفصيل، الحل بالتفصيل، ما في اختصار. لأنه ممكن طالب أقول له والله حل مختصر يكتب لي الجواب النهائي وبس، ولا خطوة والثانية وبس. الدرجات موزعة على الخطوات. فيا ريت يا أخ عمر أنت وغيرك الحل بالتفصيل. أوكي، أي سؤال آخر، أي استفسار قبل ما نبدأ المحاضرة؟ أي سؤال، أي استفسار؟
دكتور
تفضلي.
دكتور الحين أنت منزل ملفين، اللي هو الملف اللي فيه أسئلة والملف الثاني أحط فيه الإجابات بالتفصيل، صح؟ برقم السؤال ورقم الفقرة.
يعني عليك ممتاز. خليني أفتحه لزملائك ونشوف مع بعض شو اللي منزله أنا في الألماس. لحظة شوي عشان ما حدا يقول لي أنا ما فهمت. أو خليني أفتح الألماس وأعمل لكم عليه شير. طيب هذه الصفحة أتمنى تكون واضحة للجميع وواصلة للجميع. البي سي سي أنا المسؤول عن هذا المقرر. في البداية كاتب لكم بعض الشغلات اللي بتساعدكم كيف تفتح الكتاب، كيف تحضر المحاضرات. كلها هذه ملفات يعني جاهزة بتساعدكم على حتى الكالندر بتاع السمر سمستر موجود. هذا اللينكس لكل المحاضرات. في عنا تقريبا 3 شعب للمقرر، ثنتين معي وثنتين مع الدكتور خالد. بإمكانك تحضر مع أي دكتور أنت بتحبه أو أي توقيت. الكوزز والتي ام اي والفاينل زي ما ذكرنا 30 20 50 مجموع 100%. ما في على الاتندنس. التي ام اي راح يكون تقريبا في وسط جانوري، وسط 7، ممكن بلس ماينس توداي، لكن تقريبا بالوسط يعني بين ال 13 خلينا نحكي ال 17. هذه الاوفيس اورز اذا في احد حاب يرسل رساله فيها بحيث انه نكون اكثر تنظيم ونرد عليه خلال هذه الاوفيس اورز. هذا بالنسبه للفاينلز. هذا بالنسبه للكويزز. الفاينل طبعا مش ظاهر عندكم لانه لسه الصفحه مو جاهزه، لسه بدري عليه عشان ما نخربطكم. هذا الكويزز. في عندنا 6 كويزز مثل ما قلنا. السكور تقريبا في الجميع راح يكون 30. راح نحسب توب 5 زي ما احنا شايفين هنا. توب 5 كويزز راح يتم حساب وليس الستة. كل الكويزز اونلاين تقريبا 15 minutes، احيانا بنزيدها ل 20 حسب هذا. كلها مالتيبل تشويس. هذه مواعيد الكويزز، الايام، التوقيت، التايم، السبجكت، الاسبوع، كلها ساندي باستثناء اخر كويز راح يكون تيوزدي. ساندي وتيوزدي نفس الاسبوع. الكويز الخامس والسادس راح يكونوا بنفس الاسبوع، واحد احد وواحد ثلاثة. تمام. هذه اللينكس للكويزز كلها. طبعا كل كويز عشان ما حدا يخربط راح قبل الكويز الثاني اخفي الكويز الاول وهكذا، عشان يعني ما حدا يخربط، خلاص يعرف انه الكويز الاول انتهى دوره، باقي له الكويز الثاني الثالث الرابع وهكذا. هذا التي ام اي. زميلتكم تكلمت عن ملفين. ملف اسمه تي ام اي سمر اللي هو ام تي 129 ام 129 تي ام اي سمر. التي ام اي سمر هذا ملف اللي فيه الاكسرسايز، كل الكويشنز تاعون التي ام اي. الملف الثاني اللي احنا شايفينه هون هذا الموجود فيه فقط صفحة وحتى محطوطة كصورة بحيث انه يكتب الطالب اسمه ورقمه الجامعي، شعبته، فرعه، ويبدأ يحل. يضيف بيج ويبدأ يحل. اوكي، عشان يعني نتفادى قدر الامكان البلاجرز. اوكي. وهذا الكتف ديت راح ينحط الى اخره، ولازم يكون دوكيومنت مثل ما احنا شايفين. كل التعليمات هذه لابد انه يقراها. اي واحد باي هاند، لاحظوا، باي هاند راح ياخذ 0. تمام. الان البلاجرزم برضو هذه قوانين جامعة، لا مني ولا عشوائية، هذه قوانين جامعة. أوكي، راح يخضع ملفك لموقع، موقع هذا من الجامعة، بينزل ملفاتكم كلياتها وبيجي تقرير البلاجرزم، مين نسبته عالية، مين نسبته متدنية، مع مين متشابه إلى آخره. التي ام اي كفر 5 سبجكت مثل ما احنا شايفين، احنا تقريبا بالثالث الآن، راح ندخل اليوم الثالث، يعني ممكن هذا الأسبوع نختم الثالث ونصف الرابع تقريبا أو الرابع، يعني هذا الأسبوع تقريبا راح ندخل في الرابع. فالأسبوع القادم إن شاء الله راح نكون غطينا مادة الكويز إن شاء الله. ممكن يعني نحتاج كمان محاضرة معنا. هذا نصيحتي لكم، ستوب بلاجرسم. أوكي، هذا اللينك اللي هنا لابد ترفع ملفك، تضغط عليه ترفع ملفك، ملف واحد. بعد ما تتأكد ما حدا يرفع ملف لمادة أخرى راح تأخذ زيرو، يرفع شورت كات راح يأخذ زيرو، يرفع ملف فاضي راح تأخذ زيرو. هذا خطأ لا يغتفر، رجاء لا تحرجني ولا أحرجك. أنا مش كل طالب راح يرفع ملف راح أشيك وراه، أنا راح أشيك بس يخلص التايم. العدد الطلاب كبير جدا، يعني عندنا في الأم لحالها 283 وغير هناك برضو عندي عن فوق تقريبا 350 طالب. مستحيل أشيك على، أنت عندك ملف واحد مش قادر تشيك عليه وأنا عندي 350 ملف لازم أشيك عليهم؟ لا، أنا بشيك عليهم لما أجي أصحح. تمام، فيا ريت تتأكد من ملفك. طالب أخطأ في ملف أو مادة أخرى راح يأخذ زيرو، يعتبر إنه ما سلم. فرجاء يعني عشان نكون واضحين، هذه هي الأمور والتعليمات اللي مطلوبة منك في التي ام اي. هذا التوبكس، المواضيع اللي قاعدين نشرح منها، السلايد الفاضي مش الفاضي يعني اللي بدون ما أكتب أنا عليه أي إضافة، هذه يعني البيور. هذه المحاضرات المسجلة سواء إلي ولا لغيري. وهنا في عنا بعض الأسئلة لكل شابتر، كل شابتر له ريفيجن، أسئلة وحلولها، أسئلة وحلولها، يا ريت برضه تطلعوا عليه. أوكي، إذا جيت أرفع الواجب، نعم ترفع ملف الأجوبة أكيد. ليش الملفين؟ أصلا غير مسموح إنه ترفع ملفين يا أحمد، ما مسموح لك ملف واحد اللي هو ملف الإجابات. ما إلك دخل بملف الملف الأسئلة، أنا معطيك إياه، ليش ترفع لي إياه؟ تمام يا أو أحد، عفوا يا أحد يا أحمد ما بعرف. أوكي، أي استفسار آخر؟ لا هذه ولا هذا طلع عهد. أوكي
دكتور عندي سؤال.
تفضلي. قبل ما نبدأ
أم
اللي عنده سؤال يجهز لي يا شات يا يحكي بسرعة. تفضلي.
أم في أول سؤال الإكس under the radical، هلأ كيف أميز إنه هي under the radical كل الإكويجن أو بس الإكس لحالها ولا نفس الإشي؟ أو مش عارف، أنا صراحة مش قادرة أميز.
قصدك أنا بديش هسه أراجعه لأنه حاب نخلص منه أول المادة بعدين أراجعه. لكن الراديكال يعني لحد نهاية الخط تبع الراديكال التوب اللي هو الخط اللاين اللي فوق هو بينتهي الراديكال، ما إلك دخل في اللي بعده. يعني الآن راح أكتب لك، بس أنت عن أي سؤال بتتحدثي؟
أول سؤال أنا بدي أبلش أحل من هلأ. first question دكتور.
يلا يلا، لسه قاعد يفتح. هذا الراديكال لإكس واضح يعني. هل خط الراديكال ماشي لنيجاتيف 2 1 عفوا؟ لا
نيجاتيف 1 لأ، بس للإكس.
خلاص إذا للإكس
خلص
واضح يعني.
خلص تمام، شكرا دكتور.
عفوا. دكتور احنا قبل الكويز اللي راح لقينا اختبار تجريبي صراحة ساعدنا كثير. هل نحصل نفس الشيء لكل الكويزات. لا، الاختبار التجريبي أصلا فيه أكثر من مادة، أكثر من شو اسمه، أكثر من شابتر. يعني مش كمراجعة اعملوه، أما مش هو والله نفس النمط يعني. أوكي. طيب، المادة هذه أو الشابتر هذا راح طبعا أرتبه برضو بطريقتي الخاصة، يعني ما راح ألتزم في السلايد، راح أحط النيو سلايد ونكتبه من A to Z. مطلوب منا في هذا الشابتر إنه أعرف الستيشنري بوينت، الانكريز والديكريز، اللوكال اكستريما، والكونكيفيتي انترفالز، الانفليكشن بوينت، وهاو كان sketch the f of x or function and optimization problem. ففي عندي عدة مواضيع وكلها مترابطة، فأنا يعني بحب أعطي بطريقتي الخاصة مش بالطريقة اللي موجودة في هالسلايد. فيا ريت تنتبهوا معي. بسم الله الرحمن الرحيم. إن شاء الله today we will start with application of derivatives. In this chapter we will study the stationary point, how can find the stationary point, the stationary value, how can find the interval of increasing and decreasing of function, local extrema, and concavity interval, how can find also the inflection point, how can sketch the f of x. Also we have some problem in optimization problem. Okay. Tutorial number 3, application of derivatives. Number 1, stationary point. If we have the graph of f of x like this in xy plane, this is f of x, and we have here and here horizontal tangent line at A and B, and the value of f will B and f will A. At this point we have stationary point. In the point A and f will A we have stationary point. This means the slope of tangent line equals 0. So this means also f prime at A equal 0. Also in the second point we have slope equal 0. This is horizontal tangent line, and this means also f prime of B equal what? Equal 0. This B and f will be. Okay, so we can conclude, let f of x is polynomial at an x equal a and f LA is stationary point if and only if f prime لل a equal 0. So at x equal a stationary point, this means f prime lil a equal 0. If f prime lil a equal 0, so we have stationary point if f of x polynomial. Okay, now how can find the stationary point? The first example about this example, find the stationary point of f of x. Number 1, if f of x equal 2x to the power 3 minus 3x squared minus 12x plus 5. The solution, f prime, firstly we need to find f prime. If we found f prime and put it f prime equals 0 and solve this equation, so you find x equal a, that means f a equals 0. So this is a stationary point. So we need to find or solve this equation, f prime of x equals 0. To find the stationary point, solve this equation. Now, f prime of x equal 6x squared minus 6x minus 12. This is equal 0. So we need to find this solution. By divide over 6, we have the quadratic equation x squared minus x minus 2 equal 0. Now, x, we need two numbers, the product -2, the addition -1. So we have -2 and plus 1. So we have x minus 2 equals 0, x equal 2, and x plus 1 equals 0. So we have x equal -1. So we have two values that f prime at this value equal 0. So this is the stationary value. To find the stationary point, we need to substitute it 2 in f of x. So f2 equal 2 multiply 2 to the power 3 minus 3 2 square minus 12 multiplied by 2 plus 5. This equal 16 minus 12 minus 24 plus 5. So we have 16 minus 12, 4, 4 minus 25 minus 20 plus 5 minus 15. So we have the first point 2 and -15. This is the first stationary point. The second, at x equal -1, f in -1 equal 2 multiplied by -1 to the power 3 minus 3 -1 square minus 12 multiplied -1 plus 5. This is equal -2 -3 plus 12 plus 5. So this is equal to 12. The second point, -1 and 12. This is the second point. Any question? Any question? Number 2, if f of x equal x to the power 4 minus 8x square plus 10. To find the stationary point, this is the same. Find f prime. After that, this is equal 0. Solve this equation. Take x as common factor. We have 4x square minus 16 equals 0. So x equals 0, or 4x square minus 16 equals 0. We have 4x square equal 16. By divide by 4, we have x square equal 4. Take the radical for both sides, so we have x equal plus minus 2. So this is 3 value, 3 stationary point, 3 stationary value. To find stationary point, put it x equal 0 and x equal 2 and x equal negative 2. To find f is 0 equal, substitute here in f of x, 0 minus 0 plus 10 equal 10. So this is equal the first point 0 and 10. The second one, f2 equal 2 to the power 4 minus 8 2 square plus 10. This equal 16 minus 32 plus 10. So this is equal what? Minus 16 plus 10, negative 6. So the second point 2 and negative 6. Also substitute negative 2. We have negative 2 to the power 4 minus 8 negative 2 square plus 10. So we have 16 minus 32 plus 10 equal negative 6. So we have 2 and negative 2, and negative 6. Any question? Now, if we found the stationary point, why the stationary point is important? This is important to find increasing interval, decreasing interval, local maximum, and local minimum. Okay, so if we need to find an increasing and decreasing intervals, firstly, we need to find the stationary point. Look at this. If we have x and y, at A and B, and we have a stationary point here at C. Also we have apple A and apple B. Okay. Look at this stationary point at C, x equals C, with a slope 0. And look at this point at, for example, x1 that belongs to interval from A to C. We have the tangent line with the slope, the tangent line, slope of this greater than 0. So the f prime at x1 greater than 0, positive. If the tangent line positive, so the f prime positive, we have increasing function. But look at this point at x equal 2. We have tangent line with the slope for x2 less than 0. So f prime at x2 less than 0, negative. So if the f prime negative, the sign of f prime negative, we have decreasing function. Now, the increasing and decreasing depend on the sign of f prime. From A to B, we have one critical point that maybe change the function from increasing to decreasing or from decreasing to increasing around the stationary point, because the function increasing to become horizontal, after that maybe decreasing, or decreasing to the stationary point, after that go up and increasing. Sometimes we have situation increasing to horizontal tangent line and still or continue increasing, okay, or decreasing still or continue decreasing. But sometimes we have change around the stationary point. If we have increasing and decreasing, must be change around the critical point or stationary point. So if f prime positive, we have increasing function. If f prime negative from C to B, any point from C to B, this is the tangent line decreasing and negative. So we have decreasing for f of x. So we can conclude if f prime of x greater than 0 for all x belongs to the from A to C, then f of x increasing on A to C. If f prime of x less than 0, negative, for all x belongs to the from C to B, then f of x decreasing on the interval from C to B. Now, to find the increasing and decreasing function, we must study the sign of f prime around the stationary point. So, firstly find the stationary point. After that, find the sign of f prime around the stationary point. Here we have two regions because we have one stationary value. Okay, if f prime positive, so this is f of x increasing. If f prime negative, f of x decreasing. The first example about this, find increasing and decreasing intervals of f of x. Number one, if f of x equal 2x to the power 3 minus 15x squared plus 24x plus 2. The solution, firstly find the stationary point. F of f prime equal 6x squared minus 30x plus 24. By divide by 6, we have x squared minus 5x plus 4 equals 0. We need to solve this equation, quadratic equation, by factorization. X, we need to number the product 4, the addition negative 5. So we have negative 4 and negative 1. If x minus 4 equals 0 and x minus 1 equals 0, so we have x equal 4 and x equal 1. Okay, so we have two stationary value. Now, after that, put it f prime, the real line of f prime from negative infinity to infinity. And we have two stationary points at 1 and 4. So we have 3 regions. Choose any value from negative infinity to 1 to find the sign of f prime. You can choose, for example, 0. From here, we can choose 0. From this region, we can choose 2. 2 belongs from 1 to 4. From 4 to infinity, we can choose 5. Just to check f prime positive or negative. So, firstly, f prime at 0 equal 0 minus 0 plus 24. So this is positive or negative? Positive. We need positive, negative. No need the specific value. Just positive or negative. So we have the first region positive. The second region at 2, substitute 2 in f prime. 2 square 4 multiply 6 24. 2 multiply 30, we have negative 60 plus 24. This is negative because 24 plus 24, 48. This is less than negative 60. So we have negative. F prime at 5 equal 5 square 25 multiply 6 150. 5 multiply 30 150 plus 24. So we have positive. At positive increasing, negative decreasing, positive increasing like this. Okay, so we can conclude that f of x is increasing on the interval. Which one? The f prime positive from negative infinity to 1 union from 4 to infinity. And f of x is decreasing on the interval from 1 to 4 like this. Any question? طيب. Another example, number 2, f of x equal x to the power 4 minus 4x to the power 3 plus 10. The solution, the same steps. Find the stationary value by find the first derivative and equal 0. Solve this equation. We can take x squared as common factor, so we have 4x minus 12 equals 0. So we have x squared equals 0 or 4x minus 12 equals 0. Take the radicals. We can conclude x equals 0 or 4x equal 12 by divide by 4, x equal 3. Okay, now we need to check the f prime sign from negative infinity to infinity at 0 and 3. We can choose negative 1, 1 and 4. f prime negative 1 equal negative 4, negative 12, so we have negative less than 0. f prime at 1, we have 4 minus 12, also we have negative. f prime at 4, this equal 4 to the power 3, 64 multiply by 4, we have 256 minus 4 square 16 multiply 12, 192. So we have positive. Look at this, negative, negative, and positive, decreasing, decreasing, and increasing. Now we can conclude that f of x decreasing on the interval from negative infinity to 0 union from 0 to 3, and f of x increasing on the interval from 3 to infinity. Okay, any question? Now we have the subject local maximum and minimum. This means local extrema. If we have f of x like this, and we have two stationary points at A and B, and we have f A and f B. We have the point A and f A and B and f B. Look at the around the A and f A. A and f A, we can see this is the maximum. So how can find it without a graph of f of x? How can find this is maximum? By increasing and decreasing. Look at this. If we have the function increasing, look at this, increasing after, before the stationary value, and then decreasing. So we have local, this called local maximum. And if we have decreasing before the stationary and after stationary from the right increasing, we have stationary point that called local minimum. Okay, so this means if we have f prime from negative infinity to infinity and two stationary value A and B, around A change from positive to negative, from increase to decrease. So this is as the top of amount. Okay, so we can see this is the local maximum, and this decrease after that increase, so we can see this is local minimum. Okay, now we can conclude that if f prime changes from positive to negative at x equal a, this is stationary value, and change from left positive from right negative, so we can conclude f has local maximum at A and f A. Like this, increase, reach the top, and go to the decrease, so we have maximum. Okay, now if f prime changes from negative to positive at x equal B. So we can conclude F has local minimum at B and F will be. Okay, decrease negative, reach to the point, stationary point, and go up increase. So we have minimum. We have four situations for this. Sometimes F prime change around A from positive to negative, or F prime change around the A from negative to positive, or F prime not change, positive, positive. Also, F prime around the A not change, negative, negative. If we have positive and then negative, so we have A and FLA local maximum. Like this. We have local maximum at A and FLA. Increase and then decrease. If change from negative to positive, so A and FLA local minimum. Decrease to stationary point and increase. Decrease and then increase. So we have A and FLA. This is local minimum. But if not change around the A, so we don't have extrema. Extrema means maximum and minimum. So not local. Extrema, this means A and FLA not maximum and not minimum. Okay, like this, increase to increase and continue increase. Okay, also if not change around the A, negative, negative, this is not change. Also A and FLA not local extrema. Decrease and decrease. Okay, at A. Example about this. Example, find the local extrema. Local extrema means find the local maximum and the local minimum of f of x. Number one, f of x equal 2x to the power 3 minus 3x squared minus 12x plus 5. The solution. Firstly, we need to find the sign, the first derivative, find the stationary point. After that, find the sign of f prime. If we have change around the stationary point, so we have a local extrema, maybe maximum or minimum. So f prime of x equal 6x squared minus 6x minus 12 equals 0. This is already solved this equation. So we have x equal 2 and x equal negative 1. Two stationary value. If we check f prime around the negative 1 and 2, from negative infinity to infinity, we have 3 region. Now, f prime of what? Of negative 2, f prime of 0, f prime of 3. f prime of negative 2, we have 6 multiplied 4, 24, negative with negative plus 12, minus 12, so we have positive, increasing. Now, at f prime 0, we have 0 minus 0 minus 12 less than 0. f prime at 3, we have 3 square 9 multiply 6 equal 54. 3 multiply 6 minus 18 minus 12, so we have positive. Okay. Now, we can, from this graph, we can conclude the increasing and decreasing interval. Also, we can conclude the local maximum and minimum. So, we can conclude f of x has local maximum at negative 1 and f in negative 1. So we need to substitute f on f of x to find f in negative 1. This is equal negative 2, negative 3. So we have negative 12. Negative 1 multiply negative 12, positive 12. So we have negative 1 and 12. This is the local maximum. And f of x has local minimum at 2 and f2. This equal to f2, substitute f2 in f of x. We have 16 minus 24 minus 24 plus 5. So we have 16 minus 12 minus 6 minus 30 plus 5. So negative 15. Okay, look at this, f2, substitute f2, 2 to the power 3, 8, multiply 2, 16, 4 multiply negative 3, so we have negative 12, minus 24 plus 5. So this is equal 4 minus 24 minus 20, 12, 6. Sorry, this is not 15. This is equal 16 minus 12, 4. Sorry, negative 15. Sorry. Yes, correct. Second, example, to find in local extrema, if f of x equal x to the power 4 plus 4x to the power 3 plus 2. Find f prime. This equal 4x to the power 3 plus 12x square. This is equal 0. Take x square as common factor. We have 4x plus 12 equals 0. Now we have x squared equals 0. So x equals 0, or 4x plus 12 equals 0. So we have x equal negative 3. Okay. Two critical value or stationary point. Find the sign of f prime. We have negative 3 and 0. Substitute negative 4. Substitute negative 1. And substitute 1 to find the sign of f prime. Substitute negative 4. We have negative 4 square. 4 multiply negative 4 plus 12. So we have this is negative, decreasing. Substitute negative 1. Negative 1 square. 4 multiply negative 1 plus 12. So this is positive, increasing. Substitute 1. 1 square. 4 multiply 1 plus 12. Also this is positive. Now look at this, the sign of f prime. We can conclude the increase or decrease or local maximum and local minimum. F of x has local minimum. Okay, at what? From at negative 3 and f in negative 3. And substitute f in negative 3 in f of x. So we have negative 3 and 81. Okay, 81 minus 108 plus 2. So this is equal minus 25. But f of x doesn't have, local maximum. So we have minimum, local minimum, but we don't have local maximum for f of x. Okay. sure. طيب خلينا نعوض f negative 3 in f of x. طبعا يا يزيد نعوضها ب f of x. okay, لأنه هذه point for f of x, the value of f of x. So we have negative 3 to the power 4, so we have 81. Negative 27 multiply 4, so we have negative 108 plus 2. This equal 8, 1, 30, negative 23. Okay, sorry, 27. Negative 27, okay, plus 2, so negative 25. 25, yes, correct. Okay. بالتعويض ب f of x هي. Okay, عالية. Any question? This is not correct. Okay, must be put it negative 3 with brackets مع الأقواس. Okay. Okay, now the concavity. The concavity, if we have x and y axis, like this, f of x from A to C, and here we have change from A to B, and this is C, and here we have change for what? For concavity. Look at the first part from A to C, all function concave down. So this is concave down, and the second part from C to B, look at this, the function concave التقعر, concave up. Now if we have f of x change concavity from down to up or from up to down, we have with the point, this is point of changes, this called inflection point. Inflection point. We can find the concavity by using what? By using FW prime from A to C to B and C. This is C FW prime of C equals 0. So we need to find the stationary of FW prime also, that FW prime equals 0. Maybe this is the stationary at FW prime, not F prime. F prime, this is for maximum, minimum, increase and decrease. And the stationary of FW prime, or the zeros of FW prime, at this point, maybe we have inflection point. If the FW prime change of sign from left and right. If we have negative, the sign of FW prime negative, so we have concave to down. If we have positive, we have concave up. Okay, now if FW prime of x less than 0, so this is negative for all x belongs to the from A to C, we can conclude f of x is concave down on the interval from A to C. If FW prime of x greater than 0 for all x belongs to the from C to B, then f of x is concave up on the interval from C to B. Also, we can call FW prime, if changes FW prime change from positive to negative or from negative to positive, so the point C and FC is inflection point, but must be find f double prime of x equals 0. Must be find or solve this equation f double prime 0. Now we have 4 situations for this. Sometimes f double prime change around the A from negative to positive, from down to up, or f double prime around the A change from positive to negative, up to down. But sometimes also we have around the A we have positive, positive, up, up, or negative, negative, down, down. Now, f of x concave up on the interval from A to infinity, and f of x concave down from negative infinity to A, and A FLA inflection point. Also here f of x concave up from negative infinity to A, and f of x concave down from A to infinity, and A FLA inflection point. If around the A not change, concave up, up, so this is not an inflection point. But we don't have inflection, we don't have concavity down, just have concave up. So f of x concave up from negative infinity to A, union from A to infinity. And f of x not has concave down interval. And also f of x not has inflection point. Okay. In the last situation, f of x not has concave up interval, but f of x has concave down on the interval from negative infinity to A, union from A to infinity, and we don't have an inflection point. Okay. So the inflection point come after the concave down, no, come after concave down or up. Just we need to the change from down to up or from up to down. This is an inflection. Inflection means we change the concavity. At this point, change the concavity. تم تغيير الكونكافيتي من up ل down or from down to up. But if not change down, down or up, up, this is not an inflection point. Okay. Example. Yes. Find the concave up and down of f of x and find the inflection point if exists. Number 1, f of x equal x to the power 3 plus 3x squared plus 1. The solution, f prime, we need to find the zeros of f double prime. So firstly find the f prime. After that find the f double prime, and this is equal 0. Solve this equation. We have x equal -1. Okay, the sign of f double prime from -infinity to infinity around the -1. Substitute f in -2 and is 0. -2 substitute here in f double prime. So we have -12 plus 6 less than 0. Substitute 0, 0 plus 6 greater than 0. So we have negative, positive, concave up, concave down and up. Now we can conclude f of x concave up on the interval from -1 to infinity, and f of x concave down on the interval from -infinity to -1. And we have inflection point here, yeah? Inflection point at -1 and f in -1. This equal -1. Substitute -1, we have -1 plus 3, 2, 2 plus 1, 3. So we have -1 and 3. This is the inflection point. Any question? Number 2, f of x equal x squared plus 2 all to the power 2. The solution, f prime of x equal 2 multiply x squared plus 2 and the derivative of x squared plus 2 equal to x. So this equal 4x to the power 3 plus 8x. Now find the f double prime. So we need to find the inflection and concavity. We use the 0 of f double prime. So this is equal 12x squared plus 8. This is equal 0. Solve this equation. What's the solution of this equation? Give me the solution of this equation. If we put it 12x squared and move the positive 8 to another side, so we have negative 8. Okay, this is negative, but this is positive. So this is no solution. No solution for this equation. So we don't have the zeros of f double prime. Just we don't have zeros of double prime. So we have one region from minus infinity to infinity. We can substitute any number, for example 0, on the double prime here. So we have 8 positive. So this is positive. So this is concave up. We can conclude f of x concave up on R. Okay, or from negative infinity to infinity, like this. So we have inflection, we don't have inflection. F of x not has inflection point. Okay. I will put it the example for all subject together like this. Example, f of x equal 1 over 4 x to the power 4 minus 6x squared plus 16, and we need to find number 1, the stationary point of f of x. Number 2, local extrema of f of x. Number 3, increasing and decreasing intervals of f of x. Number 4, concave up and down intervals of f of x. Number 5, inflection point of f of x if exists. Number 6, sketch f of x. Okay, so we have 6 exercises for one function. Where is? Wait. Wait. Okay. Number 1, the solution. Number 1, we need to find the stationary point. So we have f of x equal 1 over 4 x to the power 4 minus 6x square plus 16. This is f of x. F prime, this equal 4 multiply 1 over 4, 1. X to the power 3 minus 12x, this is equal 0. Take x as common factor. So we have x square minus 12 equals 0. So we have x equals 0, or x square minus 12 equals 0. We have x square equal 12. Take the radical. X equal radical plus minus 12. Okay, plus minus radical 12. This equal around the approximate plus minus 3.46. Okay, this is the stationary value. Okay. If we need to find the stationary point, we must substitute the f of x wait. We must substitute radical 12 and negative radical 12 if we need to find the stationary point. This is the stationary value. So at x, for example, equal radical 12, the stationary point radical 12 and f radical 12. After substitute radical 12 in f of x, we have negative 20. And at x equal the second stationary point, negative 12, and substitute f negative 12. So we have negative radical 12 and minus 20 also. At x equals 0, we have here the third stationary value, 0 and f is 0. We have 0 and 16. Okay. This is number 1. Number 2, we need to find the local extrema. Local extrema, we have f of x equal 1 over 4, x to the power 4 minus 3x square plus 16, like this. Okay, this is f of x. Sorry, minus 6 x square plus 16. To find the local extrema, we have f prime already. Find it by x to the power 3 minus 12x, and find the stationary point x equals 0, x equal plus minus radical 12. So we need to find the sign of f prime here from negative infinity to infinity. So we have negative radical 12 and 0 and radical 12. Substitute f negative 4 here, negative 4, okay, because the minus or negative radical 12, this is 3.4. So negative 12 f prime, we have substitute here negative 64 plus 48. So this is negative, decreasing. Substitute the negative 1. We have negative 1 plus 12. So this is positive, increasing. Substitute L1. This is equal 1 minus 12, negative, decreasing. Substitute L4. We have 64 minus 48. So this is positive. Okay. Now we can conclude that f of x has local maximum. Local maximum on what? On 0 and f is 0. 0 f is 0, already founded 0, 16. And f of x has local minimum on the 2 point. The first one, negative radical 12, and f radical 2 point, negative radical 12, and f negative radical 12, and radical 12, and f radical 12. This equal negative radical 12 and negative 20, and this one equal radical 12 and negative 20, like this. Number 3, we can use the same sign of f prime here also to find the increasing and decreasing. F of x increasing on what? On the interval negative radical 12 to 0 union, and from radical 12 to infinity. This is increasing of f of x. And f of x decreasing on the interval from minus infinity to negative radical 12 union, from 0 to radical 12. Okay. To find the concavity and the inflection point, we need to use the second derivative. Number 4, f double prime equal what? Equal x to the power 3 and 3x square minus 6x square minus 6x, so we have minus 12. Okay, this is equal 0. This is f double prime. So we need to solve 3x square minus 12 equals 0. So x square equal 4, 12 over 3. Take the radical, so we have x equal plus minus 2. F double prime from minus infinity to infinity, negative 2, positive 2. We have 3 region. We can substitute f double prime at negative 3, f double prime at 0, and f double prime at 3. Substitute f double prime negative 3. We have 27 minus 12. This is positive. Substitute 0, we have negative 12, negative. Substitute 3, we have 27 minus 12, positive. So we have positive, negative, positive. Concave up, down, and up. We can conclude f of x concave up on the interval from negative infinity to negative 2 union, from 2 to infinity, and f of x concave down from -2 to 2. Also, number 5, we have inflection point. The inflection point, because around the -2 and 2, because change from positive to negative, from negative to positive. So we have change on the sign of W prime. So we have inflection point at 2 and F2 and -2 and F in -2. If we substitute 2 in f of x equal what? 1/4 x to the power 4 minus 6x squared plus 16. Substitute 2, we have 16/4 f2 equal 4 minus 24 plus 16, so we have -4. Substitute -2, also the same, -2, -4, because this is x to the power 4 and x squared, positive, negative, the same value. Now, if we need to sketch the graph, I need new blank slide. Number 6. This is x. This is y. 4, 8, 12, 16, 20. And 1, 2, 3, 4, -1, -2, -3, -4. Firstly, what is the maximum and local maximum and local minimum? We have local maximum here, 0, 16. This is the maximum. And also we have minimum at radical 12. This is radical 12, negative radical 12, and here radical 12 to 20. So we have negative radical 12 and negative 20. Here radical 12 and negative 20. This is the minimum and maximum. Also we have an inflection point at -2, -4 and 2, -4. So we have two inflection point, 2 and -4, -2, -4. We have change the color. We have decreasing and increasing, and then decreasing and increasing to infinity, like this. So we already put the maximum and minimum and the inflection. Now, after put the increase and decrease line, or like this, approximate graph or sketch, we need to determine the concavity. So we have concavity to up, okay, concavity to up from -infinity to -2. So this is must be concavity up to -2, like this, okay. sorry, wait. And from -2 to +2, this is concavity to down. From 2 to infinity, we have up, concavity to up, like this. Now we can remove this line. So we have this f of x. This is the maximum. This is the minimum. This is the inflection point, and increasing, decreasing interval already determined on the graph. Okay. Any question? Any question? Okay. Today we will finish to this subject. Inshallah, tomorrow we will study to find the optimization problem. Also the second derivative test. And inshallah, tomorrow we will finish this chapter, and maybe go to the chapter number 4. Okay. Yeah, the straight line, just to determine the increase and decrease, and to sign the concavity also, to not put the line or sketch the curve above the maximum, or sketch the curve down the minimum point, and so on. Okay, so put the line to determine the border of the curves and which maximum and minimum. Okay. Yeah, you can use application to sketch the graph, or you can put it by your hand. Okay. Any question? إن شاء الله بكرة راح نكمل هذا الشابتر وندخل في الشابتر الجديد. ضايل الموضوع أو 2 يعني في الساعة الأولى من محاضرة بكرة، في الساعة الثانية راح ندخل في شابتر 4. أوكي، يعطيكم العافية جميعا، نتمنى لكم التوفيق. دمتم في رعاية الله، والسلام عليكم ورحمة الله وبركاته.